Okay. Now, with this, let me um, state a few more, names that people use in matrix theory. So let's say image of a matrix. Well, I can always remember, I can always replace the matrix by a linear transformation T. Okay, so I can rewrite the whole thing with the same T. Just in LaTeX, if I had LaTeX all this, if I take all your notes, say control R, I replace capital T by capital A by capital T, you're done. So you'll get a linear algebra textbook, right? So what is the image of this? Well, pictorially, let me see what is the image of this, right? So this is, I'll write it in general fashion. So this is a vector space V, and this is a vector space W. What is the image of this? So essentially, there is a mapping which maps V to W, okay? Now you take each vector and see what it gets mapped to, right? What happens is if you exhaust all the vectors in V and see what it gets mapped to, maybe it gets mapped to some subset here, right? Right? If this subset is entire W, then great, but otherwise it's some subset here, right? Do you agree? So this set, I'll name it as image of A, right? Image because you know why it's an image, right? It's like you shine a light and whatever. Okay, so right. So how do I write this? It is all the vectors here, right, in W, right? So what are those vectors? It's AV such that V belongs to V, right? Right? V is a vector in V. I'll see what happens when I operate A, right? So it takes there in W. I'll collect all those AVs, right? That will give me the image, right? What can you say about the image? Is it a vector space? See, all those vectors which gets mapped to 0, we saw that it's a subspace. It's a vector space in itself. And now I'm going to take all the vectors and it's mapping. So is it a subspace? In other words, is it a vector space? So definitely this is a subset of W, right? Very clear, because obviously A cannot take a vector and map it to something outside of W. That's not possible, right? So now, is this a subspace? Again, I have to do the same logic, right? What can you say about this? How do you prove that this is a subspace? Huh? Linear combination, I think one more thing you have to verify, the 0 gets mapped to 0, but it's trivial here, right? So anyway, so how do you prove this? So I have to take a linear, let's verify if it is true. I have to take two vectors in A, right? Image of A, right? So so I'll write it, I'll write it as a claim, okay? So image of A is a subspace of W. Okay, I'll write it as question mark because we don't know. We will see if it's possible. Let's look at proof again with a question mark. If it works out, then I'll remove the question mark. Okay. Now what should I do? I should take two vectors in image of A, two numbers, take a linear combination and show that it belongs to, right? Same step. So let you take V. Let me not use V here. Okay. So what should I do? Yeah. So let's say W1, W2 belongs to image of A. Okay. You take two vectors in the set, two numbers alpha beta belong to R. Well, if your vector space is over C, then alpha beta belongs to C. Okay. Now you take these two vectors. What is it that you need to show? You need to show that the linear combination belongs to the image, right? Okay. So what does W1 belong to image of A means? It essentially means there is a vector V1 or V in V that gets mapped to W1, right? This implies there exists a W1 belonging to, let me use V1 belonging to V such that AV1 is W1. Okay. Similarly, similarly, W2 belonging to image of A implies there exists a V2 in V such that AV2 is what? W2, right? Now I can write linear combination of W1, W2 in terms of AV1, AV2, right? So this implies I have to write alpha. I'll directly, okay, I'll write it here. Alpha W1 plus beta W2, okay, belong to, this is a very sloppy way of writing mathematical proof, okay, but I want you to correct it when you scribe it. You have to write it precisely, okay. You probably have to write it in the reverse direction. Okay, so this I need to prove that it belongs to, I'll write it as a question mark. Is this true? Suppose this is true, well, this is also true, right? All that I'm doing is substituting, nothing else, okay. If I verify that this is true, then the previous statement is also true, because all that I have done is substitution. So again, I can do this, right? A alpha V1 plus beta V2. Linearity of this belongs to image of A. Question mark. Now, can you complete the proof now? What can you say about this? This guy. It belongs to V, because V1, V2 belongs to V. By property of vector space, this belongs to V. Now, what can you say about A times this vector? It should be in the image, right? So this is right, therefore this is right, therefore this is right. Then we are done, right? I'll leave it for you to write a rigorous proof. Okay, right? This gives you the idea. The moment you know this, then writing a rigorous proof is like cakewalk, right?